All right, well, good afternoon, everybody. Welcome to today's Lunch and Learn. Yay, I know, it's always a good time. We are so happy to have everybody here. Thank you today to our sponsor, Courtyard by Marriott of Cartersville. They make having this really special time where we get to chat about all these awesome science topics possible. We really appreciate that. If you've been to Lunch and Learn before, you know this is always a good time. If you want to go ahead and put the next one on your calendar, it's going to be on June 18th. We're going to be joined by Dr. Richard Esposito from Southern Company and Georgia Power, talking about the title of the talk is Clearing the Air. He's going to be talking about all the different technologies that Georgia Power and Southern Company are using to help clean up our environment and keep everything running smoothly for the planet, which is really cool. Also, since you are here today, I'm assuming we have some geology fans in the house. Is that true? One or two. All right. So you should know then that Rockfest is coming up in 2 weeks, the Southeast favorite rock show, right? That'll be here at Tellus on June 14th and 15th, so make sure that's on your calendars that you're going to come back and join us. And also, for all my younger friends in the audience, did you guys know we have camp this summer? I know, it's really cool. We're really excited. We have 3 more weeks of camp that you can sign up for still. Our forensic camp, Forensic Frenzy, is going to be the 3rd week of June. Registration will close for that actually midweek next week. So go ahead and mark your calendars for that. Come back and do that. It'll be awesome. Well, today, guys, we are joined by Dr. Bill Witherspoon from Fernbank Science Center. Bill is the co-author of Roadside Geology of Georgia. So since that book actually came out, that book came out in 2013. Bill has actually presented more than 200 walks, talks, and workshops throughout Georgia. So if you want to know anything about geology in Georgia, we got you today. We have the right guy for that. Bill completed his PhD at the University of Tennessee in 1981. With the study of the geological structure of the Great Smokies. He taught at UT Chattanooga, then investigated the structure of Northeast Alaska and adjacent Canada in the global geology section of Shell Development Company. He became a business co-owner and software developer, then began 17 years as a geoscience educator at Fernbank Science Center, part of the DeKalb County Public Schools. In 2007, the National Association of Geoscience Teachers named Bill the Georgia Outstanding Earth Science Teacher. And in retirement, his current projects include the Rock on Mother Earth podcast series and Conversations on Climate, an 8-part series at the Senior University of Greater Atlanta. You guys welcome Dr. Bill Witherspoon.
Oh. Thank you. And the guest log might need another sheet if it fills up. Yeah. Good afternoon. So I have been sending around my little guest log, a little black book. Who's got it right now? If you hold it up, if it's with you, the black book with the little sign. There it is, back there. It's trying to go around the room, and I was just saying to Hannah, it might need an extra sheet in it because I had no idea we'd have such a good crowd. The last time I gave a talk here was an earthquake talk at a lunch thing, and it was a smaller group. So it's great to have you all here. So I'm going to try to tell you how I claim that geology really made Cartersville. And I'm one of the authors of Roadside Geology of Georgia, which is a book that has been in the museum store ever since it came out here. It's what you're seeing on the right side is one of the illustrations that has Cartersville on it. In fact, Tellus Museum is right up here, pointed out as one of the cool features of the geology of this area is to come to Tellus Museum. And people get the idea from roadside geology that it might be all about road cuts. And it actually, the reason it's roadside is because it's a series that started out in Montana area and so on, that where you can write a whole book about the geology you see from the major highways, but that's not the case back east. You just have a little pamphlet if you had all the geology you could see from the major highways in Georgia. But fortunately, there's lots more to see in Georgia. But it started out as sort of a two-color thing. It looked like this, and then by the time we got to publish our book, it wound up being full color. So there's a lot more for a geology book that can be full color. And so what we try to do, in addition to the few road cuts there are, is talk about the stories behind the scenery of places like Cloudland Canyon. Who's ever been to Cloudland Canyon? Oh, lots of you, wonderful. Who's ever been to Tallulah Gorge in the northeast corner of the state, right? And even our beaches, they have geologic stories to tell. Okefenokee Swamp, that's Tybee there. But there are stories all over the state behind the geology. And so we're going to try to talk about the story behind Cartersville today. And when you're looking at the big picture, Cartersville lies along the eastern edge of something called the Great Valley, which runs all the way up like this. I'll show you the eastern edge of it looks like this. So the Great Valley runs all the way up through, even up into New York State, through New Jersey and so on. And it's a geologic feature. And one of the neat things about the Cartersville's position, as you can see, is that it's at the very closest point to the South Atlantic coast. So if you are living in this Great Valley and you want to reach the South Atlantic coast, you might come through Cartersville. In fact, people do today on 75, but probably for a long, long time people have done that. And so that's one of the connections. We'll talk about Etowah Mounds and so on a little bit about archaeologically. It makes sense for people to be living here for a long, long time. So this is where I often start my programs. This is a map of the physical map of the southeastern U.S. And many of you, if you're a kid and you've been through 5th grade, you've probably heard these names. I'm not sure if that was the year it was in the curriculum back in the day when I was still teaching at Fernbank Science Center. But many of you will note the southern half of the state is in something called the coastal plain, but not everybody knows that it's geologically distinct, that it's made up of just loose sediments, not a whole lot of rocks to stub your toe on in the coastal plain. It's loose sediments that were deposited beside the Gulf of Mexico and the Atlantic Ocean as their shorelines crossed back and forth across this. The shorelines have been back and forth. You can find beach sands with beach-type fossils right around Columbus, so the shorelines have moved back and forth across this whole area and left their sediments. In the northwest part of the state, you find similar sediments, only they have turned fully to rock. And so around here, you find sedimentary rocks. And these were also deposited along the shoreline of an ocean, but that ocean is now gone. And it's hard to imagine an ocean disappearing. But what happened was that it closed up. It slammed shut, more or less, very slowly, about the speed that fingernails grow. That's about the speed that plates move around. But it did close up, and Africa collided with North America and closed up that ocean. Now, the Blue Ridge and the Piedmont are basically areas that were everywhere from the shoreline of North America all the way over to Africa, scattered across that ocean, that got slammed in the door. And when they got slammed in the door, they got shoved underground pretty deep. So if you're in Atlanta and you walk outside and you look up and there's an airplane flying overhead at cruising altitude, that's about 7 miles up. That's how much rock was over the whole the Atlanta area. Now here in Cartersville, it's a little bit different, but the rocks of the Blue Ridge and Piedmont got shoved pretty deep underground, and that made them change. So they were no longer sedimentary rocks. Okay, so can anybody name one of the other kinds of rocks besides sedimentary? Yeah. Metamorphic, good. So most of them are metamorphic, which means they were changed by heat and pressure. But some of them got hot enough to melt and then cooled back off. And so that would be the third kind of rock. Who can name that one? Yeah. Igneous. So those are igneous rocks. So metamorphic and igneous rocks make up the Blue Ridge and Piedmont. So Cartersville is in the, I'm going to go next. Okay, yeah. Let's see. Oh, there we go. Oh, okay, there we go. So Cartersville is in what we call the Valley and Ridge, this part of the northwest part of the state, but very close to the Blue Ridge and the Piedmont. And So one of the things about this area is that you notice that out to our west, you have pretty much valleys and ridges, like the valley and ridge would suggest. And to our east, we have these more somewhat higher terrain that's related to the tough metamorphic rocks that are nearby. And so if you want to look at just the rock composition, I'm actually going to step all the way, I'm going to imagine that we put our blinders on, we don't see igneous, sedimentary, and metamorphic, we see what were these rocks, what was the composition of these rocks when they started out entirely. And so I'll take us a step away from this colorful geologic map to a map that just shows us what the rock began as. So some rocks began as sand, some began as sand and clay, etc. Some of them began as a rock called limestone. They began their life as rocks, or maybe as a seashell that eventually became part of limestone. And we're going to zoom in now on our Cartersville area here. And when we get ready to zoom in, we're going to think about these compositions of rocks. So in the coastal plain, you would just see the regular just sand and clay and all that, not much rock, as I said. In the valley and ridge in this area, you see rocks like sandstone, which is what sand turns into, or shale, which is what clay turns into, and you see the limestone and so on. But if you go in the Blue Ridge in Piedmont, the sandstone's gone through another step and it becomes a rock called quartzite, which is a metamorphic rock that's 95% quartz. So it started out at sand, but it's this metamorphic rock called quartzite. All right, so going to the Cartersville area, we start by thinking about our quartz sand stuff. And it turns out that if you cement the sand together as sandstone, or you've even taken another step in the metamorphic form into quartzite, that it becomes a very tough rock that forms the higher ground. So this is the southern end of, I think, Rocky Face, or maybe Rocky Face is just over here. This is Johns Mountain and all this area up here. This is like the Pine Mountain that's east of Cartersville is in this high area. So you get these high areas, and the soil only has this one nutrient, which is SiO2. And so there's not a whole lot for the plants. So you get plants like rhododendron and pines and stuff that can thrive in soil that doesn't have a whole lot of nutrients in it. And then if we go to the clay, clay tends to form lower ground. It tends to be more easily eroded, and it also is, a few more nutrients than the sand, but if you got a real clay soil, that's not ideal for growing your plants in. So poor drainage, etc. Now limestone has lots of stuff that plants like, and you can get away from this really acidic soil into a soil that's more neutral. And so you get fertile soils out of limestone and this related rock called dolostone. Dolostone has the magnesium in it that limestone is only calcium carbonate. Dolostone has calcium magnesium carbonate. And so you tend to get fertile valleys, except sometimes you have the dolostone, in one particular unit of a lot of dolostone, has a lot of chert. Chert is the stuff that is, you might know it as flint. It's what arrowheads are made out of, and so on. And this is just extra silica. So if you have dolostone with chert, you get the calcium, magnesium, you get the carbonate, and you get silicon again. So you have these different kinds of things in terms of the plants and in terms of the topography, because if you've got chert, you're going to have hills. If you this particular dolostone unit that's full of chert forms hills. So if we look at this view, so if you go over Main Street and you're coming into Cartersville, get off the interstate, you come over the hill, you see Cartersville, there's downtown, there's the courthouse, I guess that is. You're looking across several different rock types. The hill you're sitting on has the quartzite, that's why it's high. And then this valley is dolostone, and that's carbonate, so it's low. And then you've got the hills behind the courthouse they're shale, but there's some sandstone in them, so they're a little bit hills. And then finally in the back, there at Ladd's Quarry is in the side of this quarry mountain, and it's got dolostone with chert. So the type of rock controls this. Now, I gave this talk a silly name about from Etowah Mounds to, I think originally I wanted to make it yellow from Etowah Mounds to Pink Road Humps or something like that, because I was thinking there are places where you can see like a crossing on a street where they made a little hump, and sometimes they color that with something called ochre that we'll get to. And then I found that I couldn't find any such thing around Cartersville, so I wound up having to change it to tinted sidewalks. So, which is not nearly as catchy a name. But we'll get back to ochre later, but the reason that sidewalk is such a pretty color is because it's tinted with ochre that was quarried right here in Cartersville. So, that's looking across at that view. So if you take a sort of an aerial view that looks across the same area, this is using Google Earth, I'm going to overlay on this the geology, the geologic map. That's really the detailed geologic mapping. And this was done by a group, Randy Kath and Tom Crawford at West Georgia, John Costello, who was with the State Survey and unfortunately passed away much too soon, and Stan Bearden, who was the geologist at New Riverside and is retired. And so they did this geologic map, and I've draped it over the topography so you can see that the quartzite with phyllite is sitting up here. That makes the hills that are around. The place that picture was taken was also on this quartzite with phyllite, looking across into this flatter country. And then here's, as you go across the area, the dolostone, the carbonate, makes that flatter country, and then the shale with sandstone makes the ridge that sort of the town backs up against. And on the other side of that, there's flat country again, and there is both shale and dolostone in a unit called the Conasauga group. And then behind that is this chert, the stuff that bears the chert that makes the ridge. And then off to the left there, you have the metamorphic rocks that are in the Piedmont province, I guess is what we call it there. And that's schist that has a lot of little veins of quartz in it, so you get back up in elevation over there. Now, so across all this area, you get a river came, okay, the Etowah River. And the Etowah River then passes the Etowah Mounds is right here in this little green spot here, okay? And there's another archaeological site I'll talk about in a minute that's right here. They were put on the river, Etowah Mounds, right on this pretty fertile carbonate rock, this dolostone, and also because the river is carrying lots of good elements for plants coming out of the metamorphic rocks here. So it's a great place for fertile ground here. And when you put that together with what I showed you earlier about the bend in the trade route potential of this area, it's just a real natural that somebody would build mounds, and civilization and so on would come to this area long before the Europeans got here. And so when we look at the archaeology, there's this, the Etowah Mounds itself is like 1000 AD to 1550 AD, but there's this even older site called the Leaky site. Is it, anybody correct my pronunciation? Is that Leak or Leaky? Leak, the Leak site. Okay, thank you. So the Leak is an archaeological site that goes all the way back to 300 BC up to 650, and this is some of the discoveries there. Pottery. There's some small mounds there, and so on. This is that may be Etowah Mounds. I'm not sure. Anyway, this is a place with mounds and so on that was much older than Etowah Mounds. So for a long time, this has been a really special place for people. So getting back to looking at the geology, this is looking straight down on the geologic mapping. And so we can also think about how old these rock units are. So the rocks of the Quarry Mountain that we saw in the distance there are 480 million years old. That sounds like an enormous number, but we're going to start going back from there. So that's the youngest thing you have in the Cartersville area. And then you have the next youngest is called the Conasauga group. It's shale and limestone and dolostone. And then the next oldest is the Rome Formation. And I grew up in Knoxville, Tennessee. Around Knoxville, the oldest thing you find is the Rome Formation. It holds up Sharp's Ridge. That's the ridge that the radio towers are on and so on. So that's the Rome. And then you go back a little older here. You get to what's below the Rome, and that's the shady, called shady dolomite. It's a dolostone mostly. And then you go back older than that, and you get into what's called the Chilhowie group, and it's mostly quartzite and shale. And even older than that, you get into something that is the same age as the rocks of the Smoky Mountains National Park, where I did my dissertation work. There's just a real narrow belt of it here. So, and then you get to stuff that it was deposited on that was 1 billion years old, or a little over 1 billion. And then you get stuff that's probably way older than that, which is the Rolling Springs. So you got this wide range of ages here. Now, when you start at look at this area again in terms of these ages here are the time the shady dolostone was not that long after what we call the Cambrian explosion, which was not an actual, something blew up. The Cambrian explosion you'll probably be able to learn about in the exhibits there. Is when suddenly there were all these different kinds of multicellular life in the oceans. And so we can find some of those earliest fossils around here. So the Conasauga Shale, this probably didn't come from right in Bartow County, but not too far away, has the trilobites, which are these creatures that were related to crabs and lobsters and spiders and insects that had 3 lobes. That's why they're called trilobites, trilobite. You find brachiopods, some of the earliest brachiopods around, and you find something called Archaeoscythus, which is kind of like a sponge. So SpongeBob's relatives, his ancestors. So you have those. If I'm sort of flying over Lake Allatoona and I'm looking out, I see these units again on the topography, and like this. So if you want to go look at these rocks that are similar in age and appearance to the ones in the Great Smokies, all you have to do is drive up Allatoona Dam Road till you get to the gate. And right at the gate you see a couple of different types. The really strong, powerful, very resistant to erosion, tough rocks that part of Allatoona Dam is probably anchored on is this metaconglomerate. And it's the same stuff that makes up, up in the Smokies, it makes up a lot of the really high mountains or have this very similar metaconglomerate over them. The conglomerate is a rock that just has sand and gravel in it, and metaconglomerate is where it's gotten, the metamorphism has taken it and made it so tough that when you break it, instead of breaking around the lumps of gravel, it breaks right across them. So it's a very tough rock. And then slate, which is what started out as shale, is right next to it there, right at the gate. This is right at the gate at Allatoona. But these rocks were deposited on older rocks, and the Corbin metagranite, if you get a chance to go, school trips do this, you can go in the Bartow Quarry, I guess it is, the Vulcan Materials, which is just off of 20 there. And you get the rock it was deposited was planed down and it was deposited on top of. So these are some of the oldest rocks in the whole Appalachians. There's a whole trend of them. The same age rocks are all the way down. If you follow the Blue Ridge Parkway and Skyline Drive in Virginia, there they're right along Shenandoah National Park, these billion-year-old rocks, and they come down into northeast Tennessee and around Grandfather Mountain in North Carolina, and they're just they extend all the way down to Cartersville. And then there's this odd little place where they're appearing even farther south around Pine Mountain, and that's kind of another story about how that got there. But so we're looking at this trend of billion-year-old rocks, and we're some of the southernmost place of it. And if you want to get rocks even older, here is, if you're on you driving to the quarry, you'll see this outcrop on your left side along the gravel road to the quarry. And this is stuff that's even older, that when we don't know quite how old it was, but it was already there when the Corbin came in as a granite intruding into it about 1 billion years ago. So this was, if I talked about the ancient ocean that closed up, and this Roland Springs Formation would have been deposited in an even still more ancient ocean that closed up. So this was an earlier collision that brought together an earlier supercontinent. And in that collision was when the rocks melted and made the Corbin. So we have this, very, very old rock just to the east of you here. And then that supercontinent began to split up, something like this, where you've got hot material coming up underneath it, and things start to pull apart. You get a rift valley like you have in East Africa today, and things start to pull apart. And so we're going to come in on that story when that earlier supercontinent begins to break up. It's called Rodinia. You've heard of Pangaea is the more recent supercontinent. This one was the one before Pangaea. And so we're going to see that Cartersville would be right about here, right in the midst of this pulling apart. And in fact, some of that snowbird group stuff was probably deposited in the basin that happened when it pulled apart. So let me run this little thing here. Let's see, I may have to change this back to a regular pointer. Let's see, we'll see. See what happens here. Okay, so I'm going to start running a little animation here, if I can. How does this work? Works as a pointer, and then now I've got to make it work as a mouse here. Well, let's see what happens if I click over here, click back here, just take that off. Okay, that's what I need. Okay, so here's what I need to do. All right, so this is, MA is millions of years ago, and this is our planet with all the continents kind of around the South Pole about 600 million years ago. And if I start to run this, you're going to see it begin to split up right around. We're sitting right about in here. And I'll follow us along. Here we go. Okay. And so this is that ancient ocean that I said is now gone. It just finished opening up, and now it's starting to close up again. Now, so you'll notice this is North America. There's Greenland up here. There's Hudson's Bay, which didn't exist back then, but it's a good reference point. This is the Great Lakes, which also didn't exist back then. But if you go down the East Coast, you notice something's missing. What don't we have down here that should be sticking out about right here on the map? Florida, exactly. So we're missing Florida. So where's Florida? Well, Florida's on the other side, tucked in over here. So we'll see Florida come into the picture in a little bit. This is actually South America upside down here. There's the southern point of South America. And this is Northern Europe. There's Scandinavia. And Northern Europe's about to run into Greenland and so on. Now, here's the northern part of South America. Here's part of Africa. And there is Florida. So Florida is coming up, and it's getting ready to come in. And so now Florida comes in, and now we've sort of pieced our continent together. Now the dinosaurs aren't even walking the earth yet, okay? They don't come in till They first show up on Pangaea, which this is, and I'd say the first dinosaurs walking the earth, maybe around now, okay? And so then we've got this Pangaea kind of doing a little dance around it, and whoop, now Pangaea starts to split up here, okay? And so here's the beginning of the Atlantic Ocean. You notice Florida got left behind on our side of the ocean. And you see all these other continents. Anybody got a guess as to what this piece is right here? Well, there's Australia. So what's this one? That's India, right? Okay, this is Africa. There's Madagascar. So India kind of was a piece of its own. It hasn't made it to Asia yet. And what do you think will happen when India runs into Asia? The Himalaya Mountains is what happened when India runs into Asia, right? So India collides with Asia. And you notice Africa and Arabia are still joined together. So one of the last things that happens is we start a new ocean right there, which is the Red Sea. Okay? So that kind of takes us through the last 600 million years. And like I said, there was this previous thing we can't as accurately represent in the time before that resulted in that collision a billion years ago that made melted the rock that you find over there in the quarry at near Corbin. So now we're going to look at. Let's see, what am I looking at here? So I've drawn a line across this because that collision caused some damage around here that I want you to know about. Okay. So I'm going to slice the earth, okay? And now I'm going to pull out of the earth a section. Okay, so I pull this up. Now this is the section that Randy Kath drew across Cartersville. So this is a slice of the earth, and what he's showing is that before erosion, you would have seen all these humps and stuff like that, and these faults where one thing slides over another. So you see this red unit here has slid up a fault over the lighter yellow unit under it, and this yellow unit has slid up a fault over this one, and all this stuff back, doesn't even show how the rocks behind it that are the snowbird group and all that have climbed up over all of it on this side. So this is kind of a section showing how this happened. Now, this is what the oil industry uses a lot of to look for oil, which is they put energy into the earth and get little lines back called reflectors that represent sedimentary rock layers. And it's the same technology as they would use to do an ultrasound. You're sending sound in and you're getting little waves back. But the significant thing about this one is that if you go across the valley and ridge, you see this consistent reflector at the bottom, and that's actually the same rocks, the Rome Formation, that you see that the hills behind Cartersville are in. They're lifted up on a fault, but that's what makes the reflector at the bottom of the stack in the valley and ridge. So this crosses the valley and ridge, and it turns out that there was a profile they did through Tennessee, and they kept going, and they went all the way to around Tallulah Gorge, that general area. And they found that this same reflector from the sediments of the valley and ridge passes all the way back under Tallulah Gorge, which means that all these rocks of the Piedmont have slid over top of those sedimentary rocks, about 100 miles, okay? And that was kind of astonishing. When I was in grad school was when they did this. That was, 25 BC or something? No, not quite. It was about 1978 or so, was when they started publishing this stuff. So anyway, the part that's gotten shoved over it is the Piedmont and Blue Ridge. And as I was mentioning earlier, this was stuff that was scattered all the way across that ancient ocean. So they began as all these different materials in these scattered terrains. A terrain is a piece that has a distinct identity. Like if you went today from Australia to China, you'd cross, here's New Guinea, here's Indonesia, here's the Philippines, here's off to your right is Japan, over there's Taiwan. All these are pieces that someday, when Australia runs into China, all this stuff will get mashed together, and some poor geologist will have to figure it all out. Well, that's the west coast of the United States has this pattern of all these terrains, and so does the east coast. We've got these separate terrains. So these all kind of, over this period of time, collided into North America, then it all closed up. And so if I wanted to take you back through the story of how these terrains got together, I'll start with having colored them up on this, and then I'll take them back in time. The one that was closest to Macon, that was green, is all the way on the other side up against Africa, so you don't even see that. Okay, but we start with this yellow thing called the Dahlonega Gold Belt, comes and slides in and hits the main part of North America. Dahlonega Gold Belt, I'll be talking about that again in a little bit, because this was a terrain that was discovered by prospectors. This is where the gold occurrences come through Georgia, and they were part of this volcanic island chain. And so then this piece that Atlanta's on was way up here. We think that its collision happened way up here because at the time it's running into is the time these rocks are going through their metamorphism is a time when there's a lot of sand and gravel and stuff arriving in West Virginia and all that. So we think these were up here at that time. It was much quieter down here at that time. So then we bring the other pieces together, and then we have to slide it along. So in California, you know, there's this big thing called the San Andreas Fault, right? Okay, and that someday Los Angeles will be north of San Francisco, and everybody will have to move because nobody wants Southern Californians don't want to be Northern Californians, vice versa. But 50 million years in the future, something like that. So, but in the case of Georgia, the part that is Atlanta came down from the north. You're probably not surprised to hear that either, right? And so it comes in and assembles. And then we have to give it a big shove and send it in that last 100 miles. That's what happens when Africa collides with North America. So that comes in like this, and that's how we get what we've got today. Okay, so I mentioned that Dahlonega Gold Belt. So let's talk about a little bit about the elements that come from the earth. This figures directly into Cartersville, as we'll see in a minute. But the gold caused some of the history around here to happen, another way of making Cartersville. And Georgia had a gold rush, was the first real gold rush in this country. The 29ers, many of them actually left Dahlonega and became 49ers, applied what they learned in Dahlonega when they went to California. Not the football team. They went out there to be gold prospectors, the 49ers. The gold was first discovered in 1799 around Charlotte at the Reed Gold Mine. There's a little story about a kid that found this lump the heavy stuff, and they didn't know what it was, and they used it as a doorstop for a couple of years. And finally, they figured out that they had a gold nugget, and fortunately, they owned that land, so they became pretty wealthy, the Reed family and the Reed Gold Mine. And the reason that Charlotte is a financial capital today has to do with the fact that they built a U.S. mint there quite early on because of the gold deposits that were found around Charlotte. So gold was discovered around Charlotte in 1799. Going through Georgia, you find this strong concentration matching this Dahlonega Gold Belt, with some of it scattered outside of it. But in Carolina, much of the Carolina is in this green thing called the Carolina Superterrane, including that Reed Gold Mine. Let's see. So where am I going with this? Okay, we'll come back. Okay, so the next point is that it does come through this area. Okay, so there's that map that I had on the opening slide, and all this gold area that's just a little bit south of the bridge over Lake Allatoona, the corner of Lake Allatoona on 75, you're into this Dahlonega Gold Belt. And sure enough, there's where the gold mines plot out as the little dollar signs. These are all various gold mines. One of them is the Sixes mine. There's a Sixes Road, I think, up here near Canton that ends up, it's now in somebody's backyard where the Sixes mine used to be. But if you go to that, as I strongly advise you to, go tour the exhibits here, and you'll find this rock with visible gold in it from the Sixes mine. So there's gold just a little bit south and east of here from the Dahlonega Gold Belt. And if you want to see what it looks like in a road cut, just the big road cut that you go by on 75 just before you cross Lake Allatoona, actually, is the Dahlonega Gold Belt. So, some geologists looked and found that there were some features of volcanic rocks. This particular publication mentions that there were some pillows, which are when volcanoes erupt underwater, you get these lumps called pillows or pillow basalts. Some of that in there. So back to the history story. Why was there a gold rush in 29? Why not in 1799 when they found this in Charlotte? Well, the Reed family owned that property, right? Now, Villa Rica claims that people were quietly mining gold back there in 1826. Another discovery was made in the Carolina Belt in 1827. And then in Georgia in 1828, gold was discovered really close to Helen at Duke's Creek in 1828. But still no gold rush until this discovery. This one around Dahlonega drew 15,000 prospectors. So why did it take that long to have a gold rush? It depended on who owned the land. Okay, and in this case, this was in the Cherokee territory, and nobody was allowed to own land there unless you were at least part Cherokee. And but the state of Georgia had already expected that the federal government would move the Cherokee when Georgia gave up what's now Alabama and Mississippi. Georgia used to extend to the Mississippi River. When Georgia gave up those two territories to become new states, Thomas Jefferson said, don't worry, you'll have that corner of Georgia too. We'll move the Cherokee out. And that was a promise that went back to Thomas Jefferson. So people figured that this was the people who lived inside this boundary did not have a secure right to their land. And that indeed turned out to be true in the history of Georgia. So what happened was those people had to relocate and move to future own locations. Now, some of them were not, they weren't necessarily hanging out in, what you might think of that Indians might have been living in when Europeans first got here. Some were pretty wealthy folks, and one of those wealthy folks was a man named William Rogers, and there's a place called Rogers Ferry in Gwinnett County, and he got $2,000 for his grist mill from the federal government when they bought him out, $500 for his sawmill, which was, you can almost add 3 zeros to that now to figure out how much that's, that was valuable property. So anyway, I just think William Rogers is interesting because he had a descendant in Oklahoma. William Rogers, can anybody guess who his descendant in Oklahoma was? Will Rogers. Okay, so his descendant was Will Rogers, who said good judgment comes from experience, and a lot of that comes from bad judgment. Okay, and lots of other fun things like that he said. So anyway, so that's a little part of the history is the people who were moved out of this area to Oklahoma included that man. Okay, so I went to a symposium over at Reinhardt College not too long after our book came out, and learned some more about how the gold rush affected Georgia history. And one of the things that people say is that, it sped up the removal of the Cherokee people, would have probably inevitable, but it sped it up. So Cherokee people were removed 38, 39, and so the railway links were completed. And for Atlanta, this railroad actually runs along the eastern continental divide. Everything on this side runs to the Atlantic. Everything on this side runs via the Chattahoochee to the Gulf of Mexico. And they just did that to keep the railroad from having too many stream crossings and ups and downs. So eastern continental divide all the way from here to here. But they also wanted to connect to the interior, and so they opened up this Western and Atlantic Railway. And there was some debate as to whether it would come from over here or over here. When they chose this spot, that's what made Atlanta happen where it is. Because the state capitol is within a stone's throw of that point where they branched off the railroad and founded essentially the Atlanta. So Atlanta was founded right where they sent this one off to the northwest. And that one off to the northwest was the Western Atlantic, which of course is why Cartersville became a city as opposed to just a little settlement on a dirt road somewhere. So, now one other point that this man was making at this talk I went to at Reinhardt College was that technological experts came in because of the gold rush. And for example, there was somebody who started an iron forge so they could so you could pan for gold. You needed something to pan, or you needed other equipment from iron, made from iron. And there was iron all over the southeast, but you needed the know-how. Well, one of the people who had the know-how was named Jacob Stroop, and he's often credited with the origin of the iron industry in Cartersville. And these are two of his descendants standing by his grave, okay, which is over near Lake Allatoona. Now, look at that guy over there. Does this person's face look like anybody in the room? So that's my cousin Bill Ryan and me standing by the graveyard of our great-grandfather's great-grandfather, Jacob Stroop. So Jacob Stroop came into the area with his know-how. He wasn't born in Germany, but his family was, there was that connection with the German technology that Ken was talking about in his talk. And you may have been to this place, which is the iron furnace that Jacob's son built, called Moses Stroop, and he sold it to somebody named Cooper, Mark Anthony Cooper. So it's got a historical marker calling it Mark Anthony Cooper's Iron Works, and it mentions here that he bought it from Stroop. But Moses Stroop, who I'm not descended from, I'm descended from his sister, but Moses Stroop is also responsible for going over to Birmingham and starting the real serious iron industry that's there to this day in Birmingham. All right, so we're going back to our geologic map, and here's those gold mine dollar signs. Here are the iron mines and prospects, I think mostly mines that have been operated all up and down. And who's been to Red Top Mountain State Park? Yep. So you go to Red Top Mountain State Park and you see, you can walk a trail and you see some of these pits where they mine some of this mines. And has anybody been to when they're doing the pour at Red Top Mountain? That's very cool. You can watch them actually. They melt the iron and pour it out and all that. So that's a really cool thing to see over there. So in addition to iron, another ore that's in the same rocks is manganese, and it's not commercial now, but during World War II, when we were cut off from supplies of manganese, lots of these manganese mines became important all over the place. But this is one of the places where they got manganese. And then there's this stuff called barite, okay? And barite was still being mined up until just probably 10 years ago, something like that in Cartersville. And barite is this extra heavy white rock. It's not metallic. It doesn't look like it should be heavy. It looks just like a piece of quartz. But when you pick it up, you instantly know that it's twice as heavy as quartz is. It's about 5 times as heavy as an equal volume of water. And barite is useful because it will block X-rays. And because it's not metallic, it won't poison you. So they have you drink a barium milkshake if they want to X-ray your gut, because it blocks the X-rays. And another thing that's heavy that is good for is they mix it with drilling mud, because when you drill an oil well, you want to hold anything pressurized fluids down in the ground. And if you put ordinary mud in there, it would just splat back out in your face. But if you put this heavy mud in, then it'll keep the oil in. So it's for drilling mud. So barium's a very useful product. It's also used to as a filler to make something heavy. So I think the carpet industry might have used some of the barite as a filler to make the underlayment of the carpet heavier. I'm not sure. But anyway, so there's a lot of barite deposits. And the barite deposits are along the boundary between this Chilhowie group in brown and this shady dolostone in blue. Now, right in there with the barite deposits are the ochre deposits. And so there is a cool activity that some of you will be able to do over here, anybody who wants to, I guess, after my talk, which is to make your own paint from ochre, much of which came from some of these ochre deposits. And they're still being mined today by the New Riverside Company. And I'll show you a picture of their building in just a second. But what I wanted to show next is that this light blue is where this shady dolostone is, shady dolomite, a tiny bit here. There's some up in Hot Springs, North Carolina, and there's some up in Shady Valley, after which it's named, up in northeast Tennessee. And all these places are good mining locations, and they mine barite over here in Hot Springs, North Carolina, as they do in Cartersville. So there's a connection in between the shady dolostone or dolomite and the barite, and as well as the ochre. So one more mining thing before I get back to the ochre mining is the Ladd's Quarry, which is over, I mentioned a couple of times, over on Quarry Mountain. There are caves. When you have a carbonate rock like limestone or dolostone, slightly acid rainwater will dissolve it out over time, and you'll get caves. And so caves are found in this. The quarry was cut into this, and there are caves in there. And they used to, any old body could go in there and collect. Now it's not so accessible. But here at Tellus Museum, you can see that some of the creatures from not so distant past, as in the last couple of million years, or maybe a million, or maybe tens of thousands of years, these are animals that got into those caves or fell into sinkholes that are inside caves and got preserved. So you have these recent fossils. Also, it turned out that somebody who started a business down in Atlanta called Coca-Cola needed a source of carbon dioxide to carbonate the Coca-Cola. So you needed a carbonate rock. And one of the closest places to Atlanta you could get it would have been right here. So I believe there's a sign on the side of a building downtown about how some of the first fizz in Coca-Cola came from this dolostone in Cartersville. All right, so back to the ochre, and there's that sidewalk again that I mentioned. Okay, and it's the only current ochre mine in the Western Hemisphere, according to Stan Bearden, who was the VP of Operations when I made these slides, and then has retired since. But this is today's Cartersville. We still have mining, and it's this ochre. And actually, that's my last slide, other than just a little bit of wrapping up here. So it's kind of a good segue into possibly working with the ochre. But I'll just give you my last couple of words here. Roadside Geology of Georgia, so you can get it in the bookstore there. I think what I'll do after this talk is I'll go hang out in the gallery where you can see some of these rocks I've been talking about and fossils. So if you happen to go into the store and you buy one of these books, and you can meet me over there, and I'll be glad to sign it for you. And I can also answer questions that you might have in the gallery and that kind of thing. I don't want to take away from this activity. Hopefully, maybe you'll be able to come back and do both. But those are a couple of things you can do after this. I have georgiarocks.us. I'm not keeping up my Facebook at this point, I have to say. But georgiarocks.us has information. And finally, I'm the second author. The first author of Roadside Geology of Georgia, who brought me into her project, is Pamela Gore, who still teaches at Georgia State University, and hence doesn't have as much time as I do to come around and do programs for the public. So just a nod to Pamela Gore. And I believe that's the end of the show. So, yeah.
Dr. Witherspoon, thank you so much.
Do we have time for questions?
We'll just let you answer them separately. So,
Okay.
like Dr. Witherspoon said, we've got an activity. If you want to be able to paint with some of the minerals of Bartow County, you can move this direction over here. Otherwise, Dr. Witherspoon's going to hang out to answer questions in here and then move on into the mineral gallery if you'd like to see some of the stuff he's been talking about today, or get him to sign a copy of York, Roadside Geology of Georgia. Thanks for coming out today, you guys.
Yeah. Okay.
That was so informative, Bill. Thank you.
Thank you.